Greetings everyone. Welcome to the third part of the video for section 6.2, continuing on with our study of the graphs of the other trigonometric functions. Now I'm going to go back to my graphing calculator for a minute and take a look at the graph of secant here. And first of all, I know this is a graph of secant because I see that there is a piece here starting on the vertical axis. So we know that that is secant because then that would match up with a graph of a untransformed cosine function, which also starts there on the vertical axis like that. Okay, so that's how we know this is secant, because secant relates to cosine. And something I want to point out is, remember that with sine and cosine, we have this idea of amplitude and midline, right? Midline is the line going through the center of the function that the function oscillates above and below. And then the amplitude is the distance that the function oscillates above and below that value. Now with secant and cosecant, we don't have a value that the function is oscillating above and below. But we can still talk about the idea of a midline, because if you notice here in this graph, if I draw a line right here, in this case along the horizontal axis, so at a line like, I could label this as a function g of x equals 0, we'll notice that that goes right kind of through the center of the function, right? All of these different pieces we see here of the of the secant function line up or are the same distance above and below that. And in fact, because they're the same distance in each case, in this case it's 1, we could sort of say that the secant function here has an amplitude of 1, right? Because each of those pieces is 1 unit away from the midline. Okay, so why is that important, you ask? And maybe you didn't ask it, but I know you were thinking it. Well, if I go back to my PowerPoint here, we're going to look at graphing a secant function here by hand. And so we're given the function 3 times secant of pi over 4t minus 1, so it's been transformed. And to figure out how to draw the graph of the new function, well, we'll want to use some of the principles we use with sine and cosine to identify things that we'll call the amplitude and the midline. And then we do know that secant and cosecant have a period, and this will help us to graph the function. So first of all, for amplitude here, just like with sine and cosine, it'd be that coefficient there, so it would be a 3 in this case. The value for k would be the number added at the end. So here we see it's a minus 1. And then the period, recall that for sine and cosine, the way we find the period is by doing 2 pi divided by the value of b, which in this case our value of b would be the one on the inside there being multiplied by the variable. So we'd have 2 pi over 4, which if we do some quick algebra here, it looks like when we cancel that out, we'll end up with 8 being the period for this function. Okay, so that's going to help us draw our graph of this secant function. Now, first of all, I should point out that we're kind of, if you remember our general forms for transformed sine and cosine, we're kind of using a similar type of form here for secant, right? We could say that secant can be written as a times secant of b times t minus h plus k. And then just for funsies, we'll also write down a potential formula for cosecant, b times t minus h plus k. And I should say that even more so with secant and cosecant, because their differences in the standard secant and cosecant functions are really that one starts on the vertical axis and one starts off of it. is that we actually don't deal much with phase shifts or horizontal shifts with secant and cosecant, because if a function has been shifted off the vertical axis, it's probably cosecant. If it's on the vertical axis, it's probably secant. Okay, so let's go ahead now and use this information to draw our function. And first of all, note that the midline here is at a value of -1. So I'm going to label my axes here. I'll call this -1, -2, -3, -4, and then 0, 1, 2, 3, and 4. So again, our midline there, that's going to be at -1. So we'll have dotted line going across at -1. And then our amplitude is 3, which means that those little loop pieces or half loop pieces are going to be 3 units above and below. And because this is a secant function, we also know that it's going to start on the vertical axis. So I'm going to go on the vertical axis above the midline 1, 2, 3 units. So I'm going to have kind of the center of my first piece be there. And the next question is how to use the period and also where to input the vertical asymptotes. So recall, again, because this is secant, we know there's going to be a little loop piece up here that looks something like that. And then over here somewhere, 3 units below the midline, we'll have another loop piece, right? And together that up loop and that down loop have to cover 8 units. And they're kind of evenly spaced out, if you recall. So because of that, hopefully you would agree with me, it would make sense on this to kind of have a vertical asymptote out here at -2 for the left-hand side of the secant piece there, which let me erase this because that's going to be kind of in the way. So we'll start here. So there's the first vertical asymptote. And then we know that the end of the second loop down here, because it has to be 8 units away, it's going to be at 6, because if we go -2 to 0, that's 2 units. Out to 2 is 4. To 4 is 6. To 6 is 8. So that's where our next vertical asymptote should be. And then, of course, there's going to be a vertical asymptote in the middle there, separating these 2 loops. So there'll probably be one like this. And so we see that the vertical asymptotes are going to be every, not there, Cody, every 4 units. Okay, and again, we know that the first piece will start here going up. Have another piece inside of the next piece, 3 units below the midline going down like this. Another one going up. And we can go to the left, going down, and going up. Okay, so we would get something looking like this. All right. Okay, let's do the opposite now. So here now is a graph of a function, and we're going to try to write the equation for it. And the first thing we want to do is figure out, is this cosecant or secant? Which we can tell has to be one of them because of the kind of the loops we see. And in this case, we know that this one will be cosecant, because recall, here we see that the first loop is starting off the vertical axis. And also we could start here at 0, 0 and draw a sine function that would follow the pattern of that graph. Okay. So we know this is going to be cosecant, so we'll use kind of that general form I was just talking about for cosecant. So the f of t equals a times cosecant of b times t minus h plus k. And again, we have to find all these values. So A, capital B, H, and K. And as I mentioned at first, we can just assume that H is 0, that there's no horizontal shift here because this is a cosecant function. Next thing that might be easiest to find is where the midline is. Recall, that's going to be a line that goes through the middle of the function, which in this case, it looks like that would be right here at positive 1. So it looks like we are 2 units, each piece is 2 units above that and 2 units below. So that will make sense as our midline. So we see that our value for K there will be at positive 1. The value for A will be the distance we go above and below that, which is 2 units. And then to find B, we need to find the period, which means we also need to identify where the vertical asymptotes are. It's like we have one here, another one here, another one here, another one here, another one here. So it looks like that same pattern, that up and down pattern. So this followed by this. That is happening over this distance, which looks like it is a distance of 8 units. So that's our period, but remember that does not give us the value for B. Okay, the value for B will come from doing 2 pi divided by that period, which in this case is 8, so it'll give us pi over 4 will be the value for B. And so now we can write our equation. So we'll have in this case f of t equals the value for A, which is 2, times cosecant of the value for B, which is pi over 4, t, because there's no horizontal shift, plus 1. Okay, so that would be our function. And how could we, now that we have this, if we wanted to double check our answer, what could we do? Right, you could either graph it on your graphing calculator or go on Desmos and graph it. All right, that's it for now. Thank you for watching.